2016, paper 1, differentiation. So in question 6 here we have to differentiate the function 2x plus 4 to be squared, but we're told we have to do it from first principles. So again, if we're not doing from first principles, we'll basically end up with no marks here at all. So we start by taking the function and we let f of x equal 2x plus 4 to be squared. So what I like to do here is if I'm given something like that, I'm going to simplify first before moving on to the next step. So by simplifying it, I'm going to take 2x plus 4 and I'm multiplying it by itself. So 2x plus 4 by 2x plus 4 is going to give me the first term squared. So in other words, 4x squared. Multiply the two terms and double it. So we have 2x by 4 is 8x, and if I double that, I get 16x. And then square the second term, so 4 squared is 16. And this way, it's a little bit neater before I move on to the next step. So my next step is to replace every single x with x plus h. So in other words, making sure we're using brackets. Instead of x, I'm going to put in x plus h, and it's 4x squared, so I have to make sure that I'm going to square that x plus h. And then I have 16 times x, so again, instead of x, I'm putting in x plus h, and then I have 16, so there's no x there, so I don't do anything with that. So again, like the last step, we're going to simplify before moving on. So I have 4 times x plus h to be squared, so x plus h by x plus h is squaring the first term, multiply them and double it, and square the second term. And then I have to multiply that all by 4 in the next line. So I have 16 by x plus h, which gives me 16x plus 16h plus 16. And then multiplying out my brackets, I have 4x squared plus 8xh plus 4h squared plus 16x plus 16h plus 16. And I have no terms there that I can add, so I'm ready to move on to the next step. So the next step is where I take those first two lines and I subtract them. So in other words, I have f of x plus h minus f of x. And again, when you're subtracting, please make sure that you're using brackets, otherwise your signs will be incorrect. So we have a lot of terms here to subtract, so really important to use our brackets. Okay, so if I get rid of my brackets, I have 4x squared plus 8xh plus 4h squared plus 16x plus 16h plus 16. And then it's minus 4x squared minus 16x minus 16. So any like terms there but opposite sign, I can subtract and I get 0. So I have 4x squared minus 4x squared is 0. I have 16x minus 16x is 0. And I have plus 16 and minus 16, it gives me 0. So what am I left with? Well, I'm left with 8xh plus 4h squared and then plus 16h. So again, I've simplified, so I'm ready to move on to the next step. And my next step is where I'm going to divide that answer by h. So in other words, f of x plus h minus f of x all over h. So that gives me 8xh plus 4h squared plus 16h divided by h. So that means I'm dividing h into every term on the top line. So 8xh divided by h leaves me with 8x. 4h squared divided by h leaves me with 4h. And 16h divided by h leaves me with 16. So the very last step then is to find the limit as h tends to 0. So in other words, those 2 points on the curve are getting infinitely closer together. In other words, I'm finding the tangent of the curve. Slope of the tangent of the curve, I should say. So in other words, we're getting the limit as h tends to 0 for 8x plus 4h plus 16. So in other words, my first derivative by first principles is 8x plus 16. So in other words, wherever there's a h, I'm putting 0. And therefore, that was 10 marks. So it was a 10D question. So it's broken down into 4 parts. So we had 0, 2, 5, 8, and 10. So again, if it was not done by first principles, you were getting 0 that particular year. So in B, we have a function y equals x times sine 1 over x, and we have to find dy dx, in other words, find the first derivative. And here I have to be careful because I can see that it is actually a product. So in other words, if I rewrite that, it's x multiplied by sine of 1 over x. So in other words, we have a function in terms of x multiplied by a function in terms of x. So when I have the product, I'm going to use the product rule. So my product rule can be found on page 25 in our maths tables. So in other words, it's dy dx is equal to u times dv dx plus v times du dx. So what that means is I'm going to take the first bracket and I'm going to say u is equal to x. So if I differentiate that with respect to x, I get 1. And then I let my second bracket be v. So sine of 1 over x. And if I differentiate sine of 1 over x, well, I can't as it stands, so I'm going to write the x, 1 over x, I should say, as x to the power of minus 1. And now it's easier to differentiate. So if I differentiate sine of x to the power of minus 1, well, again, that's a function within a function. So I'm going to have to use my chain rule here. So again, remember, it's power, trig, angle, right? So I'm going to differentiate sine, and I get cos. So that's cos x to the minus 1. And then I multiply that by the derivative of the function within the function. So in other words, if I differentiate x to the power of minus 1, I bring down the power and take 1 away from the power. So that's minus x times to the power of minus 2. So if I just tidy that dv dx up, well, that's cos of 1 over x. So x minus 1 is 1 over x. And then it's minus x to the power of minus 2. So to the power of minus means 1 over. And I'm left with minus 1 over x squared. Okay, so that's my dv dx. So now if I sub that back in to my product rule, I have dy dx is equal to u, which we've said is x, times dv dx, which is cos of 1 over x, times minus 1 over x squared. And then that's plus v, which is sine of 1 over x, times du dx, which is, of course, 1. So if I just tidy up that line then, well, we have x times minus 1 over x squared. So x goes into x squared once. So that gives me minus 1 over x times cos of 1 over x, and then plus sine of 1 over x. Okay. So, of course, our derivative, you have to remember, is equal to the slope. So the slope is dy dx. So here we can see in part 2 that we're asked to find the slope of the tangent to the curve, which is what we've just found. But we have to find it when x is equal to 4 over pi. And very important here, we have to give our answer correct 2 decimal places. So we're always checking how do they want us to give our answer. So if we don't give it in the correct form, we will lose marks. Okay, so we don't want to be giving away silly marks. So our slope is equal to dy dx. So that means that the slope, when x is 4 over pi, so that's going to be minus 1 over x. Well, x is going to be 4 over pi. And that's times cos 1 over x, so that's 1 over 4 over pi, plus sine 1 over x, so 1 over 4 over pi. So I can tidy that up, or you can put it straight into your calculator. So if I'm dividing by a fraction, I'm going to turn it upside down and multiply. So that's going to be minus pi over 4. And that's times cos pi over 4 plus sine pi over 4. And of course, pi over 4 is 45 degrees. So if you know that, you can either put that into your calculator in degrees, but because this is in radians, really, we should just be going straight to calculator in radians. So we're going to say note, check your calculator is in radians. Before subbing in. Because if you sub it in and it's in degrees and you're putting in pi over 4 into your calculator, you're going to end up with an awful answer, okay? So when we put that into our calculator, we end up with, corrected 2 decimal places, the slope is equal to 0.15. So there was 15 marks in total for B part 1 and part 2. And it was broken down into 4 parts. So we had 0, 4, 7, 11 and 15. And of course I'm going to star that because it was corrected 2 decimal places for the last part there. Okay.